Now let's continue to explain a very quick explanation about damping. So damping is a very nature uh, phenomena that we can observe in our life, daily life. For example, if you are standing on a pool stilly, then you will feel nothing force except floating. However, if you're trying to move very fast inside the pool, then you feel very strong resistance force because of hydrodynamic. However, there's also inner friction or other fluid resistance, all this nature force we can observe in the real world. Uh, there's no detailed definition of what kind of force is damping force, but as we observe this kind of resistance exists, so we roughly say that this kind of phenomena that have force, resistance force that related to the velocity, that's a damping force. And also this kind of force also absorb or energy of dynamic. And we should consider that in the equation of motion. So basically, for the structural dynamic, we calculate damping by considering uh, that the damping force is the ratio of the C of the damping factor. And this damping factor is also related to 2 times of h of mk. So 2 times of square root mk we call is critical damping, which is because if the structure damping uh, becomes damping factor of the structural damping becomes to the critical damping, then there will be no dynamic vibration generated to the system because all the energy will be absorbed very fast. So only the damping is smaller than the critical damping, then there will be vibration happens here. See, the blue line is the vibration waveform that without any damping. We so call this is because there are no damping at all. And between damping, no damping, and undamped system and critical damping, all the vibration is uh, described by the ratio of the critical damping. So we call this ratio a damping ratio H here. Generally, people measure a lot of building structures about the damping, so they found that it's roughly about 0.05, 5%. So we can use H, damping ratio H as 5% in this research. Also, we should realize that the damping ratio is not only absorb energy, but also change the period of the structure. But we're going to not to discuss this problem here very detailedly.